Hello, everyone. We're just going to give everyone some time to trickle into the webinar, but welcome, welcome. And we will be getting our webinar started in 1 minute, so. All right. Good morning, good afternoon, and good evening to everyone. Thank you for taking the time out of your day to join us for this webinar. My name is Allison Davis, and I am the campaigns manager for BigAnimal, AWS's cloud database offering. I don't want to take too much of your time introducing myself as our time is limited. I would rather help you and your teams learn how you can best optimize your cloud database performance needs at a price point that makes sense to you and your organization. Today, you will be viewing live assessments of Postgres in real time. You will also get live comparisons of AWS, Azure, and AWS BigAnimal. We will assess the various price points of each DBaaS provider and conduct a performance analysis of multiple budgets to help you decide which route is best for you and your company's resource optimization. Now, before I introduce you to our speaker, please note the Q&A button at the bottom of your Zoom window. If you have any questions for us about the presentation during the presentation, please feel free to ask us using the button. We will have some time for questions at the end of this webinar. At the end of this webinar, we will also give you guys our contact information. I know that sometimes I think of questions after a webinar has already ended. So if that's the case for you, please use the contact information we provide to reach out to us. We will get back with you with an answer. I would like to introduce today's speaker, Tom Rieger, our senior client engineer here at ADB. Over to you, Tom.
Thank you, Allison. So my name is Tom Rieger, as she mentioned, and today we're going to talk about not just the technical side of cloud, because we'll get into some little idiosyncrasies, but also the cost of data processing in the cloud, and where there's a lot of potential things that become quite expensive that you may not know or realize. And then how do we bring all these pieces and parts together to try to drive an optimized result? And how can you measure things? How can you get to what does good look like? So I would like to start, by the way, by asking everyone a quick polling question. Allison, if you could open up the poll, is there a certain cloud that you're most interested in? AWS, Azure, Google, or other, or nothing defined yet? You can choose more than one, by the way. So if you are a multi-cloud organization, or you are interested in multi-cloud, check as many that make sense. I would really like to get some perspective of my audience and what's important to you. So we'll leave this open for about 10 more seconds. 5 more seconds. Come on, folks, check the button. At least you've got that dial-up modem somewhere that's kind of slow. All right, Allison, what do we have for results? I'm very intrigued with what we see for results back.
All right, so it seems like AWS is the winner with 53% of our participants choosing it. We also have Azure as second, Google third, and the rest of everyone else is saying other or nothing defined yet.
Got it. Thank you very much. All right, so let's continue this journey. So today we're going to do an apples to apples evaluation of that which is the Amazon offerings of RDS Aurora, and then we'll also run BigAnimal in there, along with in Azure with Flexible Server and our BigAnimal offering there. Please note, single server inside Azure is now being end-of-lifed, So Flexible Server is now their mainstream GA product. So with that being said, let's continue our journey. If I think about what we want as data professionals, what our employers want, we do not want to be the fastest at all costs. We also don't want to be the cheapest and slow. So you don't pick either the most expensive components or the cheapest components. You need to have a balance. And with that, if we think about that combination of technical results and financial cost, you get into this idea of a work element called dollars per transaction. But with that, the cloud brings us elasticity. It allows us to scale up or down things like concurrency, the database size, the workload. So if we think about having that as kind of a precursor where we're going to take our session today, I wanted to take a moment to share with you a lot of the things and a lot of work we've been doing here at EDB as the largest purveyors of Postgres in the world around how do we measure what good looks like. So we took a very scientific method, which is if we have minimum variables and maximum constants and consistency across all of those constants, along with using an industry accepted workload that gives us consistency in terms of the data and the work and what it does over the top of the data itself. And we also drive consistency in components. We should be able to now compare things to one another. By the way, here momentarily, I will share my screen to another monitor I have here, where we're going to kick off a side-by-side benchmark or race of these different offerings I just described. If we think about how to measure things, so let's take this from kind of the beginnings. You think about the idea of benchmarking. Benchmarking a database tends to fall into a transactional analytical environment, and the Transaction Processing Council, tpc.org, has been very much out in front of this industry accepted, globally accepted workload sets that over a database, once compared to one another, you get an idea of what a workload looks like from a numbers perspective. Now, you can do other types of benchmarking. Postgres, for instance, as PG Bench is based on the TPC B as in boy benchmark. You also have other application-centric benchmarks, like SAP has one they've been out there doing for 25 plus years. You could also go out there and run all kinds of little component tests, like IO performance, network performance, little component tests out there that are more fit for purpose for, things deep down inside. But all the while, we want to get to where we're measuring the sum of the parts. And if I think about it, and I mentioned this once, I'm going to say this a few more times. Historically, if I go Google or do an internet search for database benchmarking, whenever I get results, they tend to come back with the fastest performance at all cost. So there's no real money involved. My apologies. I'm here in the middle of the United States. It's US dollars, but it's the money side of things. It reminds me of a movie. So during COVID, I've had a chance to watch a lot of movies, some of them over and over and over again. And I love that which is Ford versus Ferrari. If you don't know the movie, in the early 60s, Enzo Ferrari and the Ferrari cars were the premier cars running at 24 hours in Le Mans in France. Henry Ford Jr. wanted to take on Enzo to win 24 hours at Le Mans. So he sent this guy named Lee Iacocca, back when he was his vice president, to go meet with Carroll Shelby out in California, because Carroll actually drove 24 hours at Le Mans and completed it, and said, what if you could build a car for us and we will give you a blank check? Now, I'm not sure about your world, but in my world, there's never a blank check. There is always an economic undertow, a financial undertow, an accountant to report to when you're doing things. My mother was an accountant, so trust me, I learned at a young age, nothing happens until finance says so. I think that was her way to say no to me a lot. But in saying that, we need to start with in how we evaluate what does good look like in data processing. And in the cloud, not like anything else we've done in our lives, we have four fundamental ingredients, four fundamental components in driving a database workload: CPU, RAM, storage, and network. Now, I've been around long enough to remember the mainframe. And for those of you who remember the mainframe was very much a shared service machine, batch operated, And when you were done with your job, you would get on the last page of the printout, because you usually got a printout, and he gave you the full detailed summary of everything that went into how this job costs your business a certain amount of money. And then for the last 30 years, we've gotten used to this idea of a data center with open systems and real-time processing, and the idea of chargebacks were much more mundane. In the cloud, we get back to, like the mainframe, you get into what I call micro billing for components. And you'll see examples of this here momentarily that are kind of almost frightening around how when you start running a database workload in the cloud, how many different line items on that invoice from an AWS or an Azure are you paying for, really? With that, we, as I mentioned, HammerDB is an open source benchmark kit that it will emulate the TPC workloads of the C and the H workload. But with that, we've done this over a lot of different sizes and clouds. And so what we are doing is we're developing all kinds of both technical and economic tools for you to take away from this so you can make your own decisions on what good looks like as you look to turn on workloads in the cloud, as you look to transition workloads into the cloud, and as you look to build net new workloads using this idea of the math at the top there around how do I optimize my CPU, RAM, network, and storage. Up to now, and I would say even today to a certain degree, we've taken this, I call it the tailored suit approach. We have to use a lot of spreadsheets and educated guesses, and I call it the reading release notes analysis to get to an idea of a size. And if you choose the wrong size, if you make it too small, your accountant is happy, but your users are unhappy. You're not getting the performance you want. Or alternatively, if you oversized it, now your users are getting the performance they want, but accountants are unhappy because you now have overspent on your budget. What we really want to do is take advantage of that which is the elasticity, and let's call it the t-shirt sizes of the cloud: small, medium, large, extra large, 2x large, 3x large. So instead of going to a department store or a men's store to buy a suit, that if I lose or gain a few pounds or kilos, it doesn't fit anymore. Now I can just go buy a couple of t-shirts, and depending on where I'm feeling at the day, I am able to be elastic to my needs. But if we take this and kind of pivot it into what the cloud offers, because in the cloud, you now have a lot of opportunities to scale up as well. Now, if I pivot this, this slide got really messed up. So if we choose the cloud and we think about the t-shirt size analogy, it is really about things like CPU and RAM are my variables and everything else is a constant. My apologies, I'll fix this on the slides you get after the fact. So if I have this idea of a t-shirt size, I could start with a medium, go to a large, go to an extra large, go back down to a medium. And I want to make sure that as I'm doing that, and as I have that as a constant, also when it comes to maybe the type of CPU, the amount of memory I have, if everything else is the same, I should now be able to compare things to one another. So let's start with the workload. HammerDB, for those of you who don't know it, if you go to hammerdb.com, it is an open source tool that was actually founded by an engineer from Intel Corporation around performance engineering. And it allows you to simulate the TPCC and the H analytics workload. And it also, what I love about it especially, is outside of the fact that it runs on Linux and Windows, it also will work across databases. So now I could take this entire methodology and maybe have one of my variables be, well, how does this run on Oracle? And then if Oracle says, this is what my result is, now let me go take this into the cloud and see how do I get a like result. The anatomy of HammerDB and the TPCC kit in the first place is it's an order processing system. So when I say that, I mean customers have orders. Orders have items. Items are in a warehouse. You pick the items off of the warehouse shelf and you ship them out to people. So you think about that, which is the iteration of that entire order processing from client to shipping out of a warehouse. And it's a very typical transactional workload with simple SQL, but large volumes of commit works. It also allows you to scale up both the database size, so you can have a number of warehouses. So you see here W for warehouses, And depending on the number of warehouses I have, that chooses the number of the database size. I can also scale up or down the concurrency. Please note, it gives you also what I would feel is a typical read-write ratio of an OLTP workload, 75-25, 75% reads and 25% inserts, updates, and deletes. And what it especially gives you as a measure out the other side, it gives you two numbers, but the most important one is transactions per minute. So you think about the number of transactions going on in that workload as a result. So it gives you this consistency that you can scale up or down from a database and concurrency perspective, and you can get a one number out the other end. So now what I would like to do is move us over to the benchmark itself. So what I'm going to do now is move us over to this screen. Yes. Okay. So what I have here on the screen is across here, you see a bunch of terminal screens in color. And I want to introduce to you that the fact that the bottom row of screens, these are my database servers. The second row here, these are my HammerDB servers. So I'll be running the benchmark. You want to run HammerDB on a separate server from the database because it can become quite CPU intensive and you don't want to starve the database. So you run that on a separate box itself. Each of these second rows of servers are 8 CPU boxes in the same region of the cloud as the database server. You'll notice here too, my database servers are all at 60 gigs, which is a 300 warehouse workload. But what I have across each column of things now is, here in my first column, here I have RDS running Postgres 14.5, set up with the latest Intel Ice Lake chips using a 1:8 ratio of compute to memory. So 16 cores is 128 gigs of RAM. Again, as a constant, I look to drive a consistent amount of IOPS across this. So I set up 300 gigs at 7,000 IOPS. Also, you'll see here, when we think about gigabytes and IOPS, that has a direct correlation in terms of cost, because I don't want to lose sight of this webinar is about money as much as technology. Secondarily, this second column is now we have Aurora running. Again, like size compute and RAM. If you don't know Aurora, one of the things I find interesting about Aurora is you have no control over the storage backend at all, but it becomes the most expensive thing you pay for. And it runs Postgres compatible 14.5. If you didn't realize this, it does not run community Postgres. They took about the bottom third of it and gutted it around the logging and the IO subsystem to create Aurora. Then we have our BigAnimal offering running community Postgres 15.1, again, running on like size Ice Lake computes with 16 cores, 120 gigs of RAM, and like RDS, I'm running 300 gigs at 7,000 IOPS. One thing about RDS is they run on the slightly older IO1 storage, which has less durability and less throughput, where in what we are doing with BigAnimal is we're always running on the latest components in the cloud. So in this case, we're running on the IO2 storage, gives you much higher durability. Let's transition over to Azure now. So Azure, I have flexible server in the blue, obviously. I did choose their latest compute they offer, which is their V4 computes. For those of you who don't know Azure, they tend to look at the flavors of Intel processors or the mix of processors they offer as V2, V3, V4, V5. If you go read the footnotes on what this means, I'm going to get an Ice Lake, which is a slightly older generation Intel, or I will get the Ice Lake Intel processor. You don't know. It is 16 cores, 128 gigs of RAM. One thing about flexible server that's a little frustrating is that for you to get like storage performance, I have to pay for and provision up to 2 terabytes of storage to get to 7,500 IOPS. They generally give you about a 4-to-1 ratio, 3-to-1 ratio of IOPS to gigabytes, and that's their standard SSD drive. They're running on a 3 release old 14.4 Postgres. Finally, within Azure, we have BigAnimal running on the latest V5. I know I get an Ice Lake compute on that with 128 gigs RAM. And so that I can have like performance here on AWS, and what I did here was 7,500 IOPS here, I decided to choose the Ultra Disks, which I do have very specific control over the IOPS to set to 7,000. And again, from a consistency perspective, running 15.1 of Postgres. If you've never ran HammerDB before, there's really two things you do. You either load it and you run it. The loading process gave me the 60 gigs of data I'm going to start with. And I have found, by the way, whether you run 60 gigs, 120 gigs, 240 gigs, you get a pretty consistent throughput in terms of transactions per minute. Where it gets interesting is when you start scaling up concurrency. But in this case, I do want to, and I'm not sure how well you can see this, but over here I'm going to do a 5-minute run up, a 20-minute run for 96 concurrent users. So what I'm going to do now is cat. This is the one and only time you'll see me ticking away at the screen here. Cat load BigAnimal. Over here, I'm going to do cat run. Whoopsie, I just say cat. It's because I want to make sure we all realize there's a consistency here in the scripts. Because again, as a constant, I have the script set to the same values of 5-minute run up, 20-minute run, 96 concurrent users. So if I go now to do this, whoopsie, and I'm going to now go into the call level interface. You can do this in a very scripted, automated way. You can also do this in Windows. It gives you a more graphical version, but I wanted to be a little more transparent and share with you more details about what's going to happen. So here we're going to go like this. We're going to go like this. We're going to go oopsie, I meant to do go. Oopsie, I got to spell right. HammerDB CLI. And then we're going to kick off this benchmark. And then while the benchmarks are running, we're going to talk about other results that we have seen already. Okay. And then here, I'm going to do this one. And then here, we're going to do this one. And now we have running behind the scenes, and you can see here on the screen, it starts with a 1 minute, it'll do a 5-minute warm up. Why are you not? Oh, what did I do with Aurora? One moment, please. Oh, choose the right script, folks. Okay, so we have a warming up going on. And then we'll see what happens here. I tested this before. I want to make sure we got everybody warming up. It wouldn't be a live race if you didn't have, and again, using Ford versus Ferrari analogy, a transmission go out or brakes not work. Okay, warm up, warm up. This one right here is going to give me troubles. So we're just going to start it again. There's all kinds of ways you can control aspects of HammerDB. And boom. All right. Now, while this is running, before we get back into the presentation, I would like to highlight that you can see here that even things like pgadmin give you the ability to roll in and look to see what's happening here within our BigAnimal environment. So here's the flexible server. And also here is the database server here for BigAnimal on Azure. I just connected to a couple of them for effect, but you can see here that tools like pgadmin as an open source tool for Postgres is available for you to use against these cloud offerings, along with one of the things that I tested this morning is my ability to, through pgadmin, to deploy a cloud instance. And within the cloud instance of pgadmin, I can choose to deploy BigAnimal and just enter my credentials. And I can now use pgadmin as my graphical front end in using cloud offerings like BigAnimal. So we'll step out of that for a minute, and let's go back into the presentation as our benchmark runs. So let's go back into here. Voila. Somehow my slides that were perfect 30 minutes ago had a font challenge. With saying that, I wanted to highlight too with there we go. Adapt, improvise, and overcome, folks. So as I just kicked off for you there, we were kicking off HammerDB as constant number one. HammerDB has a 300 warehouse setup with 60 gigs of data, 96 concurrent users with a 5-minute warm up and a 20-minute run. I've also found too, if you run it for 20 minutes, 30 minutes, or about an hour, you end up getting the same number of transactions per minute. One of the things that as the database grows, obviously you start to get a larger database you're running work against. So that TPM, if you want to run HammerDB all day, would actually start to diminish because your database is bigger. But as a workload constant, we used HammerDB. Challenge number two, though, so if I have constant number one, I've solved that. Challenge number two, which needs to be a constant, is what compute do I want to use in the cloud for my database workloads? Let me use Amazon as an example. By the way, Azure is just as guilty as this, as they offer a lot of compute offerings. AWS, for instance, has 55 different 8 CPU core environments. And I'm sorry you can't see the details there. One of the things I do want to offer is after the webinar, if you email me, I will send you my inventory of VMs and all the clouds with the prices and everything else. Because what's most important is the dollar differences. They start at $102 and go to $825. And the question is, which one's the most optimal for my workload? Which one's the most optimal for me to run Postgres against? Even within the different DBaaS offerings today, whether it's AWS or Azure, BigAnimal, or anywhere else, which compute should I choose? Which one's going to get me the right result, again, for the best price? Because within these 55 choices, you have a mix of CPU types and amount of memory you have, and the network performance, the storage between the compute, or the performance between the compute and the CPU. And you just don't, what's good look like? So within our environment, as I mentioned, we are using these isolate computes, which, by the way, one of the things I like about both clouds is these newest isolate computes cost about the same or the same as the older Cascade Lakes. And one of the things I've also found with these isolate computes across the clouds is they have actually better network performance, and they have better storage performance between the compute and the storage. So you have better I/O performance on that side as well. I'm also betting too that because with each new Intel processor, you have better performance between the CPU and the RAM, you're going to have better performance there as well. So if I'm going to think of myself as a DBA like I've been in my past, I want to get the most I can for the dollar, and that is where I found that happens. And again, over here on the Flex server, I had to use the V4 because Azure is not supporting their newest Ice Lakes for Flex server. We'll see how that comes out the other side. Challenge number 3, storage. Storage is this most amazing of confusion as far as I'm concerned when it comes to the clouds. And by the way, all 3 clouds are equally guilty in their own way. So if I use, again, as a constant here where I'm trying to get to, a certain size of compute I provision, I chose 600. And oh, by the way, I had to go up to 1024 because remember, ultra disks, I have to go binary increments. I get certain max and up tos. Now, whether you're in the United States and you're buying a car, wherever you may live, at least in the US, when you buy a car and you look at this, the sticker price of the car, there's a really big number there that is, what are my miles per gallon? Or what is my kilometers per liter? And that's kind of the best you hope to get out of the car. It feels the same way when it comes to storage. I get a lot of max and up tos with storage. And then you get into another measure, which is how many inputs, outputs per second do I get? And what is my max, and especially sustained? I love sustained. My max throughput. What's my read and write rate? How big is my pipe between my compute and my storage? And depending on which storage I choose, I get different levels of maxes and up tos on things. Now, obviously, as I go from top to bottom, they become more expensive. So, but with that, I wanted to drill into this as an observation I found in doing all of this benchmarking work across the clouds. So, but before I get into that, I want to state that our storage, again, trying to drive constants here for our workloads, was 300 gigs provisioned, or I had to provision more of a flexible server to get to a relatively same IOP. And by the way, I've also found that, for instance, with GP3 storage with AWS, for those of you Amazon people, you can supposedly tune the GP3 storage up to a certain number of IOPS. A 7,000 IOPS in GP3 is not the same as 7,000 IOPS with IO1 or IO2 storage. And again, with Aurora, I have no idea in what's happening there. But I want to take a moment to kind of drill into some confusions that go on here when it comes to the cost of things. So first of all, if we think about, and I mentioned Ultra Disks once inside Azure, you have to provision it in these, I call it discrete binary increments. So if I want 300 gigs, I need 512. But then I have these tunable parameters called IOPS and throughput. How many do I need? I don't know. They give you all kinds of ambiguous blogs on Azure to figure this out. And by the way, AWS does as well. But where this gets especially interesting is the pricing model for my gigabytes of storage per IOP and per megabyte per second. Now, mind you, I use Central US as my reference point, because as I was doing this work, I had to go to Central US, which is slightly more expensive because I couldn't get the Ice Lake V5s. I couldn't get my quota approved by Microsoft to run them in the cheaper US East. I'm sure you all have these different regions of preferences based on cost in your part of the world as well. But you see this fractional amount of money that goes into the mathematics here. More importantly, this gets confusing because as I go to a certain amount of compute size, I get this idea of max uncached disk throughput IOPS in megabytes per second, which is code for this is what you ever hope to get max out of your storage subsystem up to this computing environment. Holy heck. So do I ever hope to, if I provision 25,000 IOPS and 384 megabytes per second, that on a 16 core V4 environment, that what I will get at the other side? I don't know. And by the way, this is all max and up to. So again, like that sticker price on a car, will I ever see that type of fuel economy? So if we take all of this math and you think about what does Ultra Disk cost? Well, it reminds me of, oh, that was not fun. Hold on, we're going to reduce this to something a little more readable. There we go. So if I think about what does storage cost me for a year, it's gigabytes times this certain dollar amount, IOPS times a certain dollar amount, megabytes for this certain number of cents times 12 is how much I'll pay for that storage. But the amount you need day in and day out may change and shift. And oh, by the way, you can change all three of these variables on the fly. So how do I ever know what storage really costs? It becomes quite confusing. It reminds me of the movie Good Will Hunting. Again, during COVID, I've got to watch a lot of TV, and it is on Netflix right now, in where he's at the chalkboard doing that PhD, math challenge at MIT. I felt like I had my own challenge trying to figure out what does good look like in using Ultra Disks. Now,
hey, Tom,
yes.
Can you make sure your screen's up, please?
Oh, sure. Sorry.
No problem.
Thanks for reminding me. So, I'm sorry. So just for fun, I need to make sure I share my visual there a little bit. So it starts getting confusing here from, it's like the algebra of storage costs. And then once you throw different regions in the mix and what the price changes are, once you throw different VMs or different computing environments you're attaching this to, how does that affect things? It becomes very complicated. AWS is really no less guilty. They actually give you more storage choices. They give you more up tos and maxes for IOPS. And oh, by the way, even though they say with this IO2, you get up to 256,000 IOPS, it depends on how many gigabytes you provision on how many they'll actually give you up to. And then you get into Aurora, which again, you read all the blogs and all the materials on Aurora, you have this complex storage backend that you have no control over whatsoever. But with Aurora, and I'm afraid my font is going to be messed up, not that one, is you pay 10 cents a month per gigabyte, and then that actually turns into 20 US cents per million IOPS. But you start with this very small amount of money. And oh, by the way, just like before, in Azure, over here in AWS, they're even more interesting. So if I use these isolate compute environments, these R6Is, like we're running right now, you see here with 16 CPU, I get up to a certain bandwidth amount. I don't even get an IOP or max IOPS. I get a certain up to bandwidth. And again, very ambiguous. And I'm afraid, it did do that. Hold on a minute. Let me do a quick what happened to my font moment. And then we'll go back to this. So we have my friend, Matt Damon at the chalkboard again, trying to help me figure out, well, what's Aurora going to cost me, because it's based on the total number of IOPS in a month that I run in my Aurora environment that I have no control over. I would like to ask all of you, Allison, if you could bring up that. Do you find, is it still there? There we go. Do you find this pricing of storage in the cloud as complicated as I do? Yes, absolutely. Yes, somewhat. No, not really, or not sure. And I'm also curious, am I bringing up things that you knew already? Or, wow, that's interesting, I had no idea. So if you could please just give me some perspective on your take on storage in the cloud, I would love to get your perspective. Again, yes, absolutely. Yes, somewhat. No, not really. And Allison, you tell me when we get to the point of diminishing return here when it comes to results.
Absolutely. We're going to give it about 30 more seconds and we should be good to go.
Appreciate it.
All right, it seems like things are beginning to slow down. So I'm going to go ahead and share the results. So
perfect.
Here are the results for everyone. It is, most people said yes, they find
yes. Thank you very much. Because I tell you what, I once I started diving into this, and especially if we don't do any performance testing, if we just kind of take the cost from the AWS calculator, the Azure calculator at face value, the single largest extraneous value here that makes no sense to me is IOPS and throughput. So I appreciate your validating my confusion, because that helped me a lot. So appreciate that. All right, let's go back to it here, shall we? As I fixed some fonts that decided to, running Microsoft Office products on a Mac is a very unnatural thing. And I think I'm discovering with fonts. Now, once we we have HammerDB as a workload, we have a certain compute, we have a certain storage subsystem, and we have a certain version of Postgres. And if all of those are the same, and I just change one, even within a particular environment, it should uncover some interesting results. Because there's another variable we'll get into here once I kind of, move this green box off to the right. I found very quickly that if I just change the IOPS in my RDS environment, how much that has a major percentage of the cost of my storage in that environment and my total cost. So you see my total cost, if I purely reduce the IOPS, it could bring my total cost down by 4x. All right, So now let's run HammerDB over the top of this consistently the same way over and over and over again. There's another variable here, which is how tuned is my Postgres? If I just turn on RDS and do no tuning of Postgres at all, I'm calling that out of the box results. So if I get a result here of transactions per minute, you can see here that it almost makes sense. As I slow down my storage, it slows down the results. Now at 30,000, you notice it was a little lower. But if I take the results divided against the dollar amount, I get a cost per TPM. Because what we all want, again, Ford versus Ferrari, I'm not here with a blank check to get results. I need to be as optimized as possible, as my mother taught me as an accountant for a mother. So in this case, my most optimal result is at 10,000 because that's 11 cents a transaction. Okay, that helps a little bit. But now I can go in and tune some aspects of Postgres to optimize my workload. Here at EDB, I work with a lot of really smart performance engineers. And we had a lot of gatherings around that internally here to come up with what optimal looks like. And we've actually published blogs about this. If I go in there and tune RDS the best I can to get the best results, you'll notice my results get a lot better. So I'm calling this best efforts tuning or best efforts results. I, in some cases, increase my results by, in some cases, almost double. But you'll notice if everything else is a constant here, and I reduce my IOPS, my financial results are less. If I tune it better, I now get down to where I can get a lot better results for a lot less money, and I don't really hit kind of a wall until I hit about 5,000 IOPS with IO1 storage. This really began a journey for me and for my peers in doing this work to identify what optimal looks like, because it isn't just turn on and go. It's turn on and understand what good looks like, both out of the box when you turn it on, and also as you try to do best efforts tuning. So I mentioned too that we have a relatively constant database here in what we're doing with our workloads, whether it be 14.4, 14.5, or 15.1. So if I add all of this together, and as I have our runs happening on this other screen that we'll go back to here momentarily, I want to try to drive an optimal set of VMs, so CPU and RAM, and network as part of that, network capacities, optimal storage, and then running the latest versions of Postgres and configuration settings. Actually, a note that I don't think I mentioned, in the race or the benchmark that we're running here on the other screen, these are all environments that were turned on and had no tuning done to them. So how well do they work out of the box? Because, and you'll see this here.
I just want to let you know that we are running a little close to the end of time.
Yep.
This might go over just a little bit for everyone. I understand if anyone needs to drop off, but just wanted to keep you updated.
Perfect. Thank you very much. Yes. And if anyone has a question after the fact, if you could stay till the end, you'll see my email address and I would love to share more. So I'll try to get to the point. We've done a lot of work to get to this point. We've ran hundreds of runs across all three clouds, across these different dimensions of database size and concurrency, and even runtime, to get to what we feel is an optimal result set. With that, I do want to quickly introduce BigAnimal, which is our offering as a database service in the cloud. It is here to bring our expertise to the table. We are the largest purveyors of Postgres to the world, with the largest numbers of contributors to Postgres, in some cases by 3 or 4x to the nearest organization that offers value to Postgres. We also have an option within Postgres where we make Postgres look and smell like Oracle. So if Oracle is a problem for you and you're looking to do something else but that, we can help that journey be a lot easier. Finally, one of the things, and I'll be showing a screen here momentarily, we are coming out with in early 2023, January, February 2023, a cross-region active-to-active clustering of Postgres. The only way you'll get 5 nines availability or greater is with this extreme high availability offering that we're coming out with that will always be on the latest versions of Postgres. Now, I mentioned we did a lot of benchmarking, and this is some recent results, by the way, and these results also have one variable to them, which is storage. So if I look at Aurora as an example, and my costing in Aurora assumes 7,000 IOPS across a month. So it becomes quite expensive. If I look at BigAnimal, and if the one thing I change is storage, if storage is the single largest variable here that is just frustrating me, and I'm going to use the R6Is again with 8 CPUs and 64 gigs of RAM, you can see here that I have, starting with the GP3 storage, and again, I mentioned GP3 at 7,000 versus IO2 at 7,000, you get very different results. Here's my results, but if I take the results and I divide them either into or against the cost of the environment, you get an idea of my cost per transaction. You also flip it around. So I'm a golfer. I like lower is better. If you like higher is better, it's transactions per dollar. Either way, you get an idea of what good looks like. And you can see here where I somewhat get to the point of a diminishing return, even within AWS, in how IO2 storage connects to the R6i environment. We're also trying to drive better perf tuning on these things, so there's more data to come out. But I want to share with you an example of some of these compares so we can get an idea of what optimal looks like. Because again, optimal is not the fastest results. Optimal is the one that gets you the greatest amount of workload per dollar out the other side. So for instance, if optimal here is using the cheapest storage, I only get to that performance level. So maybe I need to do something to find a way to scale up if I need more performance. Or I take and I tune up or down IO2 storage. So let's look at the environments now. I'm going to stop sharing PowerPoint and let's get to the meat of things, shall we? Because what I want to do is get into what's going on behind the scenes. So if I go into, where is my browser? There we go. And I have Chrome. So if I go in and I look at flexible server, so if I'm in Azure right now looking at flexible server, you could see here where my flexible server environment out of the box has a degree of monitoring going on here. And if I look at my CPU utilization, it's not really very good in my benchmark right now. I'm kind of, and it's also up and down the board. It's very inconsistent in what I'm seeing, but I'm only getting about 30-35% of my CPU utilization out of flexible server, the blue box right here. If I go look at my RDS environment, let's make sure I'm on the right account. If I go in and look at Aurora and RDS, and we think about some of the other fundamental compares here, like CPU and IO, if I go into RDS and I go into monitoring, you can see here I'm actually getting, I'm really only getting about 30-35% out of it as well. So it's really not optimized in terms of out of the box to be very effective at using the resources that I'm paying for. But more importantly, again, if IOs are important, you can see here where I've got read IOs. And even though I set it for 7,000, it's averaging more like 9 on the writes. The reads are kind of looking like a heartbeat here a little bit. And if I go down here and look at the total, here's an idea of what I'm seeing in total. So it's a hair north of my 7,000 limitation here that I set in my settings for RDS, but I'm not getting very good usage out of my CPU environment. Same kind of goes for looking at Aurora. Let's take a look at Aurora real quick. So here is my read-write instance of Aurora. I am getting actually better CPU utilization out of it, out of the box. I'm actually at about 2/3, about 65-66%. But where I got most concerned, and again, I don't control the storage backend at all. But as it's doing work, if it's actually going to cost me 200,000 IOPS is what it's going through right now, which could really bloat my price here quite a bit. And that's just the writes. I got the reads going on here, but there is a total value here. For some reason, they love to stick it near the bottom, is total IOPS. If you think about that 20 cents per million IOPS that I pay for a month, I'm very quickly going to have a very high cost for my environment here at averaging 200,000 IOPS as I'm running work. Now, it's worth noting here too, before, let's see, here's what a database load looks at, by the way. So even as I look at the database load, loading the HammerDB work set, there was a lot of IOPS going on there as well. So whether I'm loading data or running a workload, what my cost for Aurora is really an unknown, scary value until I get the bill, because it's billed on a monthly basis. If I look at BigAnimal, so there's a couple ways you look at BigAnimal. You can either use the monitoring tools of the cloud. You could use PG Admin, or EDB offers a tool called Postgres Enterprise Manager that allows you to get in there. But as we have results. So in the spirit of time, instead of us looking more on this front, let's take a look at our results. So here, you'll notice that it finished all of my 96 sessions, and I get a number. Here's my transactions per minute out of RDS. And what I want to do in the spirit of time and us running a little bit over is I have a spreadsheet. So I have a spreadsheet here where I mapped the cost of the environment. So here's my annual cost for RDS. Here's my annual cost for Aurora. Again, assuming 7,000 IOPS. Here's my cost for BigAnimal. Here's my cost for Flexible Server. Here's my cost for BigAnimal and Azure. And if I take that number right there and I just drop it right there, you get an idea of, on an annual, using an annualized cost basis, it's 9 cents a transaction, or I get about 11 transactions per dollar out of a year. If I look at Aurora, Aurora gave me a slightly better number. So it gave me better performance, but my cost is so much higher that my cost per transaction is double RDS. Now let's see how BigAnimal did in AWS. Oh my goodness. So out of the box, BigAnimal gave us twice the performance for about the same price as RDS, which means that it cost more than half the price of RDS and almost 1/5 the price of Aurora. So rather you look at it as cost per TPM or transactions per dollar, this is where lower is better and higher is better. Let's take a look over here at Flex Server. Oh my gosh, this is horrible, Flexible Server. Flexible Server, on the other hand, in like environment, gave me horrible results untuned, and it cost me 27 cents a transaction. And then BigAnimal over here in Azure gave me better results, but not nearly as good as AWS, for 15 cents a transaction. Again, the moral of the story here is we need to think about not just the performance, the technical performance of the environment, but what does it cost, and take one and divide it into the other. Again, whether it's dollars per transaction or transactions per dollar, which one wins for your workload? So with that being said, I'd like to finish up the session here as we're running a little over on time. And I move back to stop sharing. I go back into PowerPoint. Thank you everyone for your attention as I move things around. Let me find Zoom again. Too many things going on my screen. And then here we go. All right, finally, so let's compare. We compared the technical side, the financial side. I want to compare fundamentally what you can do from a capacity perspective. So if I think about, again, max storage, again, my font decided to act up on me here. And I found this very interesting too. Flexible Server in Azure is limited to 16 terabytes. We can go to 65 using UltraDisks. On Amazon, we're about on par. Azure or Aurora does offer more, and we are coming out on Google in Q1. I mentioned too the tunability of Postgres. So we did out-of-the-box performance testing. If I went in and started tuning things, I control almost all of my Postgres parameters inside BigAnimal. Inside these other offerings, you control a half or a hair more. Flexible Server is about half. Over here in RDS, you get almost 2/3, and so on. And then there's also the idea of HA and disaster recovery. All these other offerings give you 35 days of backup recovery that gives you things like point-in-time recovery. BigAnimal can go up to 6 months. But with that backup, and this is where it gets, again, the cost. BigAnimal, we use the blob storage of the cloud that by the way, across all clouds is about 2.3 cents per gigabyte per month. But if you look at Flexible Server and RDS especially, they charge you 9.5 cents per gigabyte per month. That can add up very, very quickly. But finally, when you have a problem, when you need help, we offer up 24/7 break fix support. We can go in and break fix Postgres if there's a problem. And we give a response time under 15 minutes with a remedy under 4 hours. These other clouds are, we'll get to you and we get to you kind of thing. In fact, I was amazed that Amazon gives you 4 hours with their best efforts. And even here in Microsoft using their Pro Direct support, you hope to get a response in 60 minutes. You don't know what a remedy time is. What's next? We're looking to do other benchmarking of other databases. We're looking to publish more materials, and we're looking to help drive some math, some worksheets, and some materials to help you truly optimize. I put that in green on purpose. The US dollar is green backs. So optimizing the cloud. And we're not done innovating. So here at EDB, in our BigAnimal environment, there's always a degree of evolution going on like you would expect from a platform. If you go look at the release notes of all these other offerings I was just showing you, the most that they talk about is just upgrading to the newer version of Postgres. We're bringing cross-region availability. We're bringing cross-cloud availability. We're adding new regions all the time. Performance. We're doing all kinds of things that are very specific to Postgres, like let's move the logs off to their own disk volumes. Automation. We're doing all kinds of automation around auto clustering and auto provisioning or auto sizing of storage, but also we're coming out with an automated tuner called PG Tuner that will not just, when you turn it on, set up Postgres to a certain value, but as Postgres is running, it can automatically adjust how Postgres is running based on the workload. And finally, and most important, cost optimization. How do we drive things like hibernate and resume to only pay for what's on? How do we make sure that we give you the results of the things we just showed you here from the sum of our efforts here to optimize what you pay for within your cloud? I hope you took away from here, a lot of that, which is how the cloud can be expensive if you don't watch out. Some of the confusions that I think from the polling question, I think I conveyed the confusion a little bit, especially on the storage side. And you want to work with the right vendor to focus on Postgres. If you go to all the vendors, they're like going into a big store and they do a lot of everything for everybody, and they don't do any of it very, very well. We're here purely focused on Postgres database and cloud. We do it very well. And also consider how you can use HammerDB to replicate for yourself what I just showed you. In fact, if you reach out to me, I will gladly give you my scripts that I use in doing that. Allison, I know we're up against the time here, but I would like to see if there are any questions we should answer, or maybe an alternative is, because we're near the top of the hour now, we take all the questions that were asked and I will respond to them on a one-on-one basis so I can be thoughtful in the responses.
Absolutely. So right now, actually, I'm going to probably give us just like 1 or 2 questions at most in the sake of time. But in the meantime, I am sending out a survey for everyone. And let us know if you're interested in seeing BigAnimal in action. So you guys will be seeing a survey pop up real quickly here. We're going to go ahead and launch the survey up. But in the meantime, I do have a few questions that a few people asked. So one of the questions we see here, let me pull it up right here, guys, is, has there really been so little DBaaS evolution by the cloud providers themselves?
Yes. In fact, if I think about when I first started this journey in comparing and contrasting these about 2 years ago, I've seen zero change out of Aurora and RDS, really, outside of maybe offering new compute environments to choose from and or new versions of Postgres. But otherwise, in terms of the functional capabilities and even the things you're allowed to change and tune in Postgres have not changed at all. Thankfully, Microsoft came out with flexible server. So anyone who's on single server, they are end of lifing that, and we can help you with migrating off a single server if you like, as it still only supports up to version 11 of Postgres. Oh my gosh. And so they've kind of come out with something and they're just letting it run, where, one of the things you should be getting from the cloud, and from some research that I've been involved in, I would say one of the top 3 reasons you go to the cloud is innovation. The other 2 are cost and ease, but innovation is there. What's lacking in all these other offerings is really any kind of net new innovation.
Awesome. And we have another question here. The question says, I live in Singapore. Does BigAnimal run in a cloud region near me?
Yes, it does. We are in multiple AP regions in both clouds, Azure and AWS. One of the nice things about our focus as well is our ability to provision BigAnimal in new regions is very straightforward. And also in evolving what we do. Prime example, 90 days ago, we did not support the newest isolate compute in Azure. We do now. In fact, we also support other computing environments with very large memory addressing. So in terms of our ability to flex into either a geography that's required by you or to use other types of compute or cloud components by you is one of the things that we're always working on behind the scenes.
Awesome. And we have one more question for this sake of time, really. And someone asked, is BigAnimal compatible with EDB Advanced Server?
Yes. So for those of you who don't know EDB Advanced Server, when I mentioned Oracle compatibility, that's a lot of what our advanced server is. And when you provision BigAnimal, you actually have a choice. Do you want to use community Postgres or advanced server Postgres? And that is just part of the provisioning cycle. And there's no real difference in how they operate outside of the fact that advanced server can consume all of those Oracle data types, can consume all of those stored procedures of Oracle and run inside Postgres.
All right, awesome. Well, thank you everyone for spending time with us today. If your question was not answered, please feel free to contact Tom or myself. You will also receive a follow-up email after this webinar containing a recording of the webinar as well as the slides. I hope you guys have a fantastic day and we hope to hear from you guys soon. Thank you for everything.
And one last thing before we come down, this is a continuing effort by myself and the team I work with. If there is something that you saw today that you have an idea of something you would like us to try and test for you, and it makes sense, please reach out to me. I want to make sure that you have input in what's going on here. Along with, I mentioned a couple of different tools that are spreadsheets and data points I put together, like the library of virtual machines in Azure and AWS with their price points. If you'd like a copy of that, reach out to me. And finally, I'm an avid user of LinkedIn. So don't hesitate to, connect with me on LinkedIn. I'm the only Tom Rieger in Minnesota, USA, I think. So please find me.
Yeah, well, thank you guys. And thank you all who attended. I know it's multiple various time zones. I hope you guys have a great rest of your day. Same thing with me. If you guys want to contact myself, my name's Allison Davis, LinkedIn as well. I'm in the Baltimore region, so a little bit more East Coast. But thank you all for your time and have a great rest of your day. Thank you.
Thanks, everybody.